So, good day everyone. Our topic for today is a continuation of our Capstone research or thesis project. Okay, so since our thesis 1 or Capstone project 1 required to have a chapter 1 to 3, so therefore we're going to discuss chapter 3. So, last time we discussed already the chapter 2 on how we'll be able to look for different review of related literature. So, by this time, we are focused on writing the design and methodology of our proposed system or software. Here is our intended learning outcomes from Outcomes-Based Practical Guide to Thesis in Capstone Project Writing in Computing by Lavina, Charlemagne, et al. At the end of this chapter, the student is expected to apply the appropriate methods in his research capstone project undertakings, determine information requirements, plan how to gather data considering time constraints, and enumerate the software features of the proposed system software. Another, of course, is described in detail how the software will be assigned, formulate the conceptual, the input process output diagram, systems architecture, and others of the proposed system. And recall the different standards used in the software design and development. First, identify the most appropriate standard or standards to be applied in software designs and outline the procedures in designing and developing the proposed system. Okay, writing the design and methodology. In writing Information Technology and Information System Capstone Project, the Commission on Higher Education suggests that the methodology, results in discussions be written under one title. However, the authors humbly suggest that the results and discussion be provided under a separate chapter. Nonetheless, the following discussion will guide the students what to write the design and methodology regardless of the capstone project template they are using. The methodology. Okay. Actually, Ernie Suzila Ishak and Rose Alenda Alias defines methodology as a systematic, theoretical analysis of the methods applied to a field of study that comprises the theoretical analysis of the body of methods and principles associated with a branch of knowledge. And typically, it encompasses concepts such as the paradigm, the theoretical model, phases, and quantitative or qualitative techniques. A methodology does not set out to provide solution. It is therefore not the same thing as a method. Instead, it offers the theoretical underpinning for understanding which method, set of methods, or so-called best practices can be applied to a specific case, for example, to calculate a specific results. The methodology is the general research strategy that outlines the way in which a research project is to be undertaken and, among other findings or other things, identifies the methods to be used in it. These methods described in the methodology define the means and modes of data collection or sometimes how a specific result is to be calculated. In writing the methodology, the students are expected to apply their competencies gained in the courses in application development and emerging technologies, system analysis and design, software engineering, among others. Thus, before designing the proposed system, the proponent must first determine information requirements. Hence, under methodology is the subsection requirement analysis. The book of Lavina et al. Has an example in the research entitled Ay Bantay, an interactive cross-platform mobile application for open government data access. The methodology proper without other components reads in part. So, the methodology of the said title, okay, or the said proposal, the study uses the new form of software development methodology known as the Agile methodology. The attempts to develop the system incrementally by building a series of prototypes and constantly adjusting them to user requirements. It emphasizes continuous feedback in each incremental step is affected by what was learned in the prior steps of development. The proponents of the said Capstone project would like to emphasize that in writing design and methodology, students should not be required to choose from among the research method as we discussed in our chapter 1 of this Capstone project book unless necessary. This is because thesis and capstone project writing in computing is a culminating activity that generates an output useful in the development of a solution. In so, doing what is involved is the integration and application computing knowledge. Simply stated, design and methodology in computing involves design of solution, not just mere data collection. Thus, if at all, the students will gather data as in the case of the IT and Information System Capstone project. The data gathered shall be used as input to the system design and development. The data gathered cannot be used as basis where conclusion of study may be drawn. This is to distinguish computing thesis, capstone project from thesis in social sciences, education, and feasibility studies. In the Commission on Higher Education templates for IT, IS Capstone project, there is an implied message that capstone project always involve the descriptive method. This is because of the requirements analysis and documentation which focuses on the present and prevailing conditions of the organization under study. Be that as it may, our thesis or capstone project template must be flexible considering the wide range of computing topics and the rapid and fast development of the field of computing. Thus, if there is an additional method other than the descriptive method, we suggest that the students or proponents expressly mention it at the beginning paragraph of the design and methodology. In this case, the research entitled The Alternative Prototype for Improving Windows Method of Data Transmission for Copying and Moving Files will serve as a good example. Again, in demonstration of the book author, methodology, this study has undergone prototyping and experimental method. The prototype had to be received, redesigned, and implemented before it undergoes an experimental test with our existing Windows 7 default file transfer utility. The following subsection describe the concept and design of the prototype and how the experiment was conducted. It is done by Jason P. Sermeno and Anrem J. Balontong and Drea Balontong during the Insight 2014 presentation, research presentation. Beginning with the end in mind, please recall the part of the CHED suggested template for methodology. Notice that under the IT and IS Capstone project, CHED provides for more specific subsection for methodology. However, as we stated at the beginning of the chapter, we recommend that results in discussion be included in chapter 4. So as what we have here, for the CS thesis Foundation of Computer Science, proposed solution to the problem, for CS thesis Software Development, Design and Methodology, and for IT, IS Capstone project cover, methodology, result in discussion, requirement analysis, requirement documentation, design in software, system, products, and or processes, development and testing where applicable, description of the prototype where applicable, implementation plan, of course the infrastructure deployment where needed, implementation results where applicable. Of course, the requirement analysis, as the outset, the student proponents should bear in mind that the proposed system or software must be computing solution to address the needs of an organization. Thus, the proponent must first determine information requirements with regards to the specific organization under study. At this phase, the proponent or proponents needs to know the details of the current system function, who, the people who are involved, what, the business activity, where, the environment in which the work takes, when, the timing, and how the current procedures are performed of the business or organization under study. The proponent must know and analyze why the business uses the current system. There may be good reasons why the organization is using the current methods, and this should be considered when designing a new proposed system. The programmer, system analyst, or software engineer, no matter how brilliant they are, cannot design the software which will serve as computing solutions addressing the needs of the particular organization unless they familiarize themselves the needs of a particular organization, unless they familiarize themselves how much organization perform their business. So if the student or proponent want to design a system that will automatically prepare class schedules as well as faculty loads for the university or colleges, he needs to interview the right person and be knowledgeable on how to prepare class schedules and faculty teaching loads without conflicts in room scheduling before he can be able to design programs that will accomplish the same. After determining information requirements and the proponent strongly believes that improvement may be done, he may propose the same of the organization under study in order to impress upon the reader and most of all to the members of the panel of examiners that the proponents had already determined information requirements. Data flow diagram should be provided under this section as well as the organizational operational framework. Another here is the current technical sample. Okay? So, of course, we need to consider their technical current situation. That's why during interview, we need to know everything. The available technology there as what they have, of course. For example, their available software. For example, their architectural, their IT infrastructure, that the technical expertise of the people, no, and so on. Then I have also an example of a data flow diagram here on a, of course, in a payroll system. So this example again is for payroll. So as you can see here, we have a lot of a symbol here, most commonly four symbols, no, which represent, for example, this one, the payroll one, is represent the input output or the internal or external entities. No, this will be the process. We have a flow line here, no, and at the same time we have a data storage. No, so this will be the symbol of a data storage. This will be the symbol of a process. This will be, of course, flow line, and this will be an internal. This will be an internal internal entity, and this will be an external entity. Requirement documentation. In some schools or colleges and university, functional requirements instead of requirement documentation is being adopted. Thus, in the research entitled Developing an Automated Student Academic Record Management with Business Intelligence Approach by Professor Maria Dara Saquin of the MC College Foundation and Dr. Dave E. Marshall of Charlemagne University, uses functional requirements instead of requirements documentation. The following discussion will guide them, the students, what to write under requirement documentation or functional requirements. The terms are just the same. However, in the text, we will be using requirement documentation. Before the commencement of software design, requirement documentation must be provided. This is a legal requirement in a real-life situation. Recall that one of the student outcomes, program outcomes being fully addressed by this course is the ability to recognize the legal, social, ethical, and professional issues involved in the utilization of computer technology and be guided by the adaptation of appropriate professional, ethical, and legal practices. And this requirements documentation is not required in a computer science thesis involving foundation of a computer science. In real-life application, the requirement documentation establish the basis for agreement between the customers or clients and the developers, programmers on what the software product is to do. In Capstone project, this is the basis of the panel of examiners as well as the advisors in determining whether the prototype developed by the students will be accepted unconditionally, accepted with conditions, or rejected. Under this section, all software features are enumerated in details by providing a storyboard showing how the software would look like if the same was already designed and coded. Requirements document states what the software will do. It does not state how the software will do it, and this is because requirement documentation is written both for the programmers and the client. Hence, customer or clients can understand the requirement documentation if the programmer or proponent will provide what the software will do. Therefore, the requirements documentation does not include database schemas, normalizations of tables, system architectures, description of communication layers, in short, no statement of design of any sort. The answer to the question how the software will do or statement of design shall be addressed under results and discussion. Verizon provides a good example. It is requirement for a word processing application to be able to open an existing file. It is a design issue whether to build a customized file selection tool or use a platform standard file selection tool. The requirements document brings the following additional benefits. Number one, the customers can see early on if their needs will be met. Number two, the developers can estimate the effort involved in creating the application. Number three, the development project leader has a basis for a project plan. And number four, the quality assurance people have a basis for testing the application. And obviously, the proponent will need data gathering tools in preparing his requirements, analysis, and documentation. The textbook of Lavina and the group of deans give an example of a requirement documentation. Capstone entitled An Online Payroll System with R3 Report Generator of SSS and Employee Monitoring for EDCAR Manpower Services. Based on that paper done by Salvatierra Meldigi Ortez, Cedric Ezequiel Sanchez, with Enrico Chavez, stated on their requirement documentation, project in scope and out scope. On their in-scope account module, for example, this module will utilize an employee management that makes adding, editing, and deleting of employees. The system also shows details of the employees such as active and inactive, among others. Another module is, of course, the payroll module. This module will create a reliable and accurate payroll system that will generate report based on different primary keys such as employee, dates, and others. The report may include at the option of the users the following: SSS contribution, PhilHealth, union dues, pag-ibig, loan payment, among others. And another, of course, is the file archive mode. This module will provide a data file archive that allows backing up of files and data records that can be exported from the database or databases. And normally, the requirement documentation consists of 5 to 10 pages, including the figures. Design of software, system, products, or processes. As simply stated under design of software system, product and or processes, the proponent shall describe in detail how he will design the proposed system in accordance with the standards. The authors, in order to simplify the distinction between computer science, thesis, and IT or IS Capstone project, strongly suggest that the design and methodology provided by CHED for computer science involving software development and design of software system, product, and or processes provided by CHED for IT-IS Capstone project should be given the same name, say design and methodology. The only difference is that the requirement analysis and requirement documentation shall not be required for computer science thesis regardless of the topic. As to the contents of the design and methodology in computer science, focus should be given on the technical aspect of the software to be developed in a way that demonstrate comprehensive of the trade-offs involved in design choices for design of software, system, product, and processes. Focus should be given on how the requirement analysis and documentation have been complied with, especially those possible trade-offs presented within the given requirements under various constraints. In this manner, graduate attributes or program outcomes or student outcomes of each program will be properly discussed. So, a responsible thesis or capstone project advisor or panelist may be required the proponents to include in this chapter, among others, conceptual design, data models, system architectures, and block diagrams. This is because most of the time, students are good in giving the characteristic of an imagined software in its finished form only to realize during Thesis 2 or Capstone Project 2 that he had no idea how to design the code to arrive at the desired result. The conceptual design, input price output diagram, and system architecture will be show that the student have an idea on how to identify, formulate, and solve computing problems. So as what we have here, okay, we have an example of a system architecture. So it shows the MIS, of course, of a payroll system. Okay? So then the next one will be an example of course, aside from the system architecture, an input process output or IPO chart may be provided if applicable. So the figure on the IPO is providing in the same or about the conceptual paradigm. Now, development and testing. Most thesis and capstone project advisors and examiners had an opinion that this subsection, development and testing, may be incorporated in the subsection design of software systems, products, or processes. We also subscribe to that opinion. However, since we introduce in this text the relevance of requiring computing students to take note of it, apply mathematical foundation, algorithmic principles in computer science theory in the modeling and design of computer-based system in the way that demonstrate comprehension of the trade-offs involved in design choices for computer science, or design information system in terms of general quality attributes and possible trade-offs presented within the given requirements for information system, and design computer-based system, processes, components, or programs to meet desired needs and requirements under various constraints for information technology and BS in entertainment multimedia computing. The Lavina in the group therefore strongly suggests that the standards to be used in software development as well as how it will be tested should be included under this section or this subsection. This will enable computing students to comply with international standard. And after all, higher educational institutions envision their graduates to be globally competitive few years after graduation. In this chapter 3, under the subtitle Development and Testing, standards to be used and trade-offs involved in the design choices shall be discussed in hypnosis only because the detailed discussion of its actual application and how the researchers or designers finally come up with the final design shall be discussed in chapter 4, results and discussion. An illustration or example of making mention of standards and trade-offs involves example, in designing, developing, and evaluating the proposed scheduling expert system, the proponent shall be using the ISO 9126-1 software quality model. ISO 9126 is an international standard for the evaluation of software. It identifies 6 main quality characteristics, namely functionality, reliability, usability, efficiency, maintainability, and portability. Thus, in order to ensure that the software conforms with the standard, it should be evaluated by an information technology experts. Therefore, the data analysis plan should be included under this subsection. The following is an example of the data analysis plan. In the dissertation entitled Towards E-Governance and Bridging the Digital Divide, a study on the acceptability of multipurpose community information and telecenter prototype by barangays in selected municipalities, the data analysis plan was written in this wise. The data analysis plan, after gathering data, the statistical tools that will be used in the analysis of data are the weighted arithmetic mean, standard deviation, analysis of variance or ANOVA, and the person product moment coefficient of correlation. The weighted arithmetic mean will be used to determine the average responses for each item of the 5 options in each item in the questionnaire. Namely, of course, 5 is strongly agree or very good or very willing or very high. 4, agree, good, willing, high. 3, undecided or fair. 2, disagree, hesitant or low or 4. And 1, strongly disagree, very hesitant, very low, very 4. And the Likert scale can be generated by means of the respondent's application in the survey. So as what we have here, for we have 5 points, 4 points, 3 points, 2 points, and 1 point. It depends upon you. For example, if you wanted to use strongly agree, agree, undecided, disagree, strongly agree. Very good, good, fair, hesitant, disagree. Very willing, willing, fair, low, very low. Very high, high, fair, low, poor, or very poor. It's up to you. Okay? But again, the option or the choices depend upon to your questions. Okay? Take note. This one has also a required an answer to a question. So sometimes it is applicable to use strongly agree, agree, undecided, disagree, and strongly agree rather than using very willing, willing, fair, low, and very low. It depends upon to your question, student or researcher. Okay, interpreting the weighted mean, the following scale will be used. To be exact, of course. Okay? Because the weighted arithmetic mean will be used to determine the acceptable of the newly developed prototype from the 3 different classes of municipalities. Standard deviation will be used to determine the degree of dispersion or disagreement among the respondents. To determine if there is a significant relationship between the barangay officials' level of acceptable of the MCIT prototype and this requirement for effective and extensive ICT use, the person-product moment coefficient of correlation will be used. To determine if there is any significant difference on the level of acceptability of the MCIT prototype in extent of ICT use as perceived by the respondents from the three levels of municipality, one-way ANOVA will be used since the research calls for comparison of the mean of three groups. The F test is a global test, and as such, only one test in an analysis is done. When the F ratio is significant, the researcher then seeks to find out exactly where the significant difference lies. Because the significant ratios merely inform him of an overall difference among the three groups who gave their acceptance level on the MCIT prototype. The significant differences may lie between Class A and Class B municipalities, and between Class A and Class C municipalities, and between Class B and Class C municipalities. It may be possible to have significant differences in only two or one pair of means. The SHIP method, or S method of multiple comparison will be used to determine where the significant difference lies. The S method may be used not only for groups that may be equal or not in number, but also for the comparison of a combination of means. It is more rigorous than the Tukey method and other multiple comparison methods because it can reveal real significant differences. It is very easy to apply because it makes use of the already computed MSW by First Gosson mentioned. The S method is not affected either by violation of the assumption of normality and homogeneity of variance unless these are gross. Normally, even in the graduate studies in computing, comparing or determining whether a significant difference exists between two or more groups are not necessary. Why is this so? In education or social science researches, the subject of survey is the people. For example, if we need to survey how many families in barangay A has annual salary of 2 million, we have to get the appropriate number of samples. Why? Because it is the people who is the subject of evaluation. Conversely, if we want to evaluate the software which we have developed, we do not need to have hundreds of experts to determine the acceptability of our software product. Why? Because the subject of evaluation is not the people, the IT expert, but the software product. Therefore, 5 IT experts evaluating your software product will suffice. Thus, knowledge about weighted mean, standard deviation, and Likert scale are enough to do software evaluation. As a matter of fact, requiring survey and the statistic is just an exemption rather than the rule. So, actually, in CHED, latest policy and standard of computing programs state that it is expressly understood that computing thesis and capstone project not need require surveys, statistics, and descriptive method unless appropriate. When will these tools be appropriate? It is when you evaluate the finished software product. The actual application and results of this evaluation shall be discussed lengthily in Chapter 4 on results and discussion. Standard and trade-offs will be discussed in the next chapter. This will be an example of an implementation plan. The implementation plan describes how the information system will be deployed, installed, and transitions into an operational system. The plan contains an overview of the system, a brief description of the major tasks involved in the implementation, the overall resources needed to support the implementation efforts, of course, including hardware, software, facilities, materials, and the personnel who used or who intended to use the system or software, and many site-specific implementation requirements. For practical reason, although an implementation plan is relevant in the real applications, it would be impractical for the students to include in the scope of their capstone project the implementation of the software product which they have developed unless the implementation is the main objective of the Capstone project. This is possible if the software had been developed and the main objective is to effectively integrate IT-based solution into the user environment and or to deploy and use tools and techniques necessary for information system practice. Nevertheless, it is under the discretion of the students and his or her advisor whether or not to include the implementation plan in the scope of his project. If the Capstone project already involves design, development, and evaluation of computing solution, the implementation plan may not be required. For computer science thesis covering computer science foundation, in computer science thesis dealing with computer science foundation, requirement analysis and documentation is not applicable because these research problems do not deal with business organization. Instead, Chapter 3 of the thesis dealing with computer science foundation must include under Chapter 3 a portion which contains the proposed solution of the problem. And recall that a thesis is a technical report on a systematic investigation of a problem that can be solved using computing. It may include a solution, an appropriate partial solution, a scientific investigation, or the development of results leading to the proponent solutions or solutions to the problem. Hence, the proposed solutions to the problem outlines your proponent solutions to the specific problem desired in Chapter 1. The solution may be an original solution, absolute solution, partial solution, an extension to, an improvement of, or even a disproof of someone else's theory, solution, or method. To the mind of the book author, the absence of the specific subsection of design and methodology as well as a proposed solution to the problem for computer science thesis is an indication that HEI or higher education institutions are very much at liberty to include what they think is appropriate. For problem description as demonstration of the author, these are various application areas that are established yet and for which new ideas and modes are presently under development and evaluation. These are domains in which the possibility of rapidly building new applications is essential and strategic form a practical point of view. Example of application domains that can be classified in this category include web-based education, electronic commerce, biology, and financial market. An interesting strategy for developing new application for this domain is the development of object-oriented application frameworks. And frameworks can reduce the cost of developing applications since it allows designers and implementers to reuse their previous experience with problem solving at the design and code levels. Prior research has shown that high level of software reuse can be achieved through the use of object-oriented frameworks. An object-oriented framework captures the common aspect of family of applications which can be seen as domain theory. Although object-oriented software development has experienced the benefits of using frameworks, a thorough understanding of how to identify, design, implement, and change them to meet evolving requirement needs is still object of research. Techniques such as design patterns, meta-object protocol, refactoring, and class reorganization have been proposed to support framework development and cope with some of the challenges. Therefore, framework development is very expensive, not only because of the intrinsic difficulty related to capturing the domain theory, but also because of the lack of appropriate methods and techniques to support framework specific and design. The proposed solution, this dissertation or thesis proposes a new method for object-oriented framework design and instantiation. In Roberts and Johnson, states that developing reusable frameworks cannot occur by simply sitting down and thinking about the problem domain. No one has the insight to come up with the proper abstraction. They propose the development of concrete example in order to understand the domain. The design strategy presented here is quite similar, analyzing concrete application as viewpoints of a domain and deriving the final framework from the analysis of these viewpoints. The approach to framework design is based on the idea that any design can be divided into the two parts, the kernel subsystem design and the hotspot subsystem design. The kernel subsystem design is common to all the applications that the framework may be generate, and the hotspot system design describe the different characteristic of each application that can be supported by the framework. The hotspot subsystem uses the method and the information provided by the kernel subsystem and may extend it, because the kernel structure is defined by analyzing the viewpoints design representation to produce a resulting design representation that reflects a structure that is common to all chosen viewpoints. This part of the design approach is based on the domain-dependent semantic analysis of the design diagrams to elicit the common features of the framework design structure and is formally described in this dissertation or thesis. Sample. The elements that are not in the kernel are the ones that vary for each application and depend on the use of the framework. These elements define the framework hotspot that must be adapted to each related application. We define new relationship in object-oriented design called the hotspot relationship to specify all the hotspot in the system. The semantics of this new relationship is given by the design patterns essential, and this implies that the hotspot relationship is in fact a meta relationship that is implemented through a design pattern that is generated taking into account the hotspot flexibility requirements. The hotspot cards guides this generation process, providing a systematic way for generating design patterns based on flexibility properties. The common way to instantiate a framework is to inherit from some abstract classes defined in the framework hierarchy and write the code that is called by the framework itself. However, it is not always easy to identify which code and where it should be written, since frameworks class hierarchies can be very complex, especially for non-expert user. Therefore, the common instantiation process is not always the ideal way to describe a particular application. This happened because of several facts. Number one, the language used to build and use the framework is a wide spectrum language where it is not always easy to express the user intentions. The complexity of framework class hierarchies and the difficulty of finding the points where the code should be written that are the framework hotspot or flexible points. The instantiation method proposes a different process where a particular application is described by domain-specific languages that are designed precisely for the framework domain. In this way, the technique basic idea is to capture domain concepts in the domain-specific languages, which help the framework user to build code in an easier way without worrying about implementation decisions and remaining focused on the problem domain. The specification written in the domain-specific languages is translated for the framework instantiation code through the use of transformational system. And now, since we already finished with our chapter 3, you are now ready to defend your chapter 1 to 3. And since we have already a discussion with on how to create your title, to to do your chapter 1, and last time the review of read literature, and today we shared on how to create or to craft your chapter 3. I researched writing the design and methodology. That's it for today. Good luck to your pre-oral defense. Thank you and Godspeed.